Good evening, Condiban. So now we can see the periodic table. So far we have seen about two important properties, namely, good evening, Kanishka, uh, ionization potential or ionization enthalpy, and radius of the atom. So good evening, Dhanalakshmi. Radius of the atom is of types: atomic radius, ionic radius, covalent radius, etc. Good evening, Sri Vishnu and Joel Samraj. So this radius of a system, radius of an element increases along the group because of the creation of newer shells on the addition of incoming electrons, whereas radius decreases along the period, horizontal row of element, because effective nuclear charge increases, but the added electron may go to the same shell. That is called that is why it decreases along the period. So with respect to radius, two important, so radius of the cation is the smallest, radius of the atom is neutral in the mediums, and radius of anion is the largest. For particular ion, whether it is cation or anion, the effect is improved. More effect is more if it is more charge. More positive ion means more reduced size. More negative ion means more increased size, like that. And the factors influencing we have seen the valence shell configuration, valence shell electron, screening effect. These are the major factors which influence the radius. Second one, we have seen about the ionization potential. Ionization potential is the energy required to remove an outermost electron from the valence shell of an atom. So this good evening, Kannappa Rajendran. Ionization potential is of types: first ionization potential, second ionization potential, third ionization potential, meaning that energy required to remove one electron, two electrons, or three electrons. All these are only outermost electrons, valence shell electrons from the atom. So generally ionization potential increases with the along the period, because along the period effective nuclear charge increases. Nuclear charge increases means it will attract more effectively the electrons towards the nucleus, or electrons are moved towards the nucleus. It is very difficult to remove. You have to supply more energy to remove an electron. So ionization enthalpy increases along the period and decreases along the group, because along the group size increases, outermost shell electron has least control over the nucleus. You know the effect of Coulomb's law. Coulomb's law is states that the attractive force is inversely proportional to the square of the distance. If the valence electron goes, can I explain again which one? So good evening, Superman. Good evening, Ganesh and Superman. So Kandapan Rajendran, we are discussing about the ionization potential, what we have seen last class. Ionization energy is the type of okay, good, let me all of you wait for a while. So last class we left with the concept of ionization enthalpy, discussion on the concept of ionization enthalpy. So good evening, Harshit. Ionization enthalpy is the energy required to remove the outermost electron from a new atom. It is also called ionization enthalpy or potential. It takes the unit of energy. It can be kilojoules per mole or kilocalories or electron volt. As in the interconversion. These are only numerical values. So ionization potential is of types. First ionization potential, second ionization potential, third ionization potential, like that. So energy required to remove one electron from a neutral gaseous atom X, that is called first ionization potential. Energy required to remove two electrons, for example magnesium forms, sodium forms sodium plus electron. So for sodium it is first ionization potential. For magnesium, in order to form its cation, it has to lose two electrons. So you have to supply more energy, because if it loses one electron, it becomes positive charge. Electrons are negatively charged. Opposite charges attract each other. So you have to supply excess energy against the attractive force. That is why ionization second ionization potential is greater than the first ionization potential. Similarly is the case with the aluminium. Aluminium, it has to lose 3 electrons. So this is for third ionization potential. So generally third ionization potential will have the maximum value. Second ionization potential have minimum value. If nothing is specified, we have to consider only first ionization potential. Whether it is not mentioned, second, third, etc. If it is just mentioned as ionization enthalpy, it means first ionization enthalpy. That's what I have told. So all these are there. Energy required to remove the second electron most loosely bound in the gaseous state of unit positive ion plus M plus is called. So X plus gaseous atom losing one more electron to form X plus 2 gaseous. Good evening, Talavar. So energy is required. So second ionization potential is more positive. So generally ionization potential is always positive. This is endothermic reaction. It increases with first is the least, first potential, second potential is medium, like that. So ionization potential 2 is greater than 1 because of difficulty to remove the electron from a positively charged species. Already we have discussed. Any doubt in this? This was discussed last class. Now you all let us see the multiple choice, then only we will have the idea. Good. The ionization potential is the energy required. Energy required means it should be always positive. For this choice, this is positive. Second, all this. Second question, ionization. Right. Next is the factors influencing. Let me rush the last class we have discussed these factors influencing ionization potential. Atomic size. Atomic size is inversely related to ionization potential, we have seen. Nuclear charge is directly related to ionization potential, we have seen. Third one, screening effect is inversely related to ionization potential. These are the fourth one, penetrating effect. S orbital is having maximum penetrating power. It is nearest to the nucleus. then only comes p orbital, then only comes d orbital, then only comes f orbital. So f orbital is farthest from the nucleus. So the penetrating effect is decreases in the order s is greater than p is greater than d is greater than f. We have seen. More the penetrating effect, more difficult is the removal of electron. We cannot easily remove. We cannot remove one electron from hydrogen. It is in the 1s orbital. We can remove one electron from sodium, but we cannot remove all in the first group only. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. All are only first group. But sodium we can remove easily one electron. But hydrogen we cannot remove one electron because sodium removed electron is in the third shell. Whereas in hydrogen the electron to be removed is in the first shell. It has maximum penetrating power. S orbital has maximum penetrating power. It is very difficult to remove. So penetrating power is directly related to the ionization potential. Lastly, half filled and completely filled configurations will have extra stability. So it is very difficult to remove electron from those. Nitrogen, atomic number 7 electrons. If you write electronic configuration, 1s2, 2s2, 2p3. P orbital maximum capacity is 6, but it has only 3 electrons, half filled. So it is greater stability. These all we have seen last class. Now let us move to the aspect on electron gain enthalpy. Electron gain enthalpy. So last two important properties we got to study today. So energy released when, so for example, if you have an element, to this you add electron, it will become negatively charged. This process is generally exothermic, generally, not everywhere. Means that it releases energy. It releases energy. So we have seen that in ionization energy, energy is required. Whereas in electron gain enthalpy, when one atom gains one electron, it releases energy. That is called electron gain enthalpy. Energy released when an atom gains one electron. That is called electron gain enthalpy. The other name for electron gain enthalpy is also electron affinity. Both mean the same. Electron affinity or electron gain enthalpy, they are equal. Now let us see the definition. Electron gain enthalpy, when an electron is added to a neutral gaseous atom, it is converted to anion. The enthalpy change is negative, so it releases an energy. That is called electron gain enthalpy. So generally enthalpy is denoted by the letter H. We will study in thermodynamics once again. Energy is E, temperature is T, H is called enthalpy. At present, you remember, you will see what is the difference between energy and enthalpy a bit later in the other chapter, thermodynamics. At present, you can take it as energy and enthalpy are almost same. Almost same. But enthalpy is denoted by the letter H. Delta denotes changes. Delta denotes change. So enthalpy, delta H means enthalpy change. H2 minus H1 or HP minus H1. Enthalpy of HR. Enthalpy of products minus enthalpy of reactants. Why is ionization energy positive? See Vishnu, listen for a while. Energy is conventionally taken as positive if it is to be supplied. And in this case, these four properties, electron gain enthalpy and ionization potential, let us consider only two properties. Ionization potential and also electron gain enthalpy. Energy is considered as positive if it is supplied, whereas energy is considered as negative if it is released. Energy released is considered as negative. For example, you have given some x rupees to some other body, what is the amount you have gained? You will tell it as minus x. So loss incurred is viewed as negative gain, like that. If energy is supplied, that is considered positive. But if the energy is released, it is negative. But ionization means a neutral atom is converted to cation. Neutral atom is converted to cation. For that purpose, you have to remove electron. You have to remove electron. Removal of electron will not take place spontaneously. Removal of electron, we have to supply energy. We have to supply energy. So here ionization it refers only to the cation formation, not for the anion formation. Not for the anion formation. That is to be noted. Doubt clarified? If you have any more doubt, you can raise, because the negative aspect, that is minus value, we are considering now. So electron gain enthalpy is the energy released. Energy released means, here what is delta H? Delta H is the energy of products minus energy of reactants. Here product is X. So energy of X minus, product is X minus. Product is X minus. Energy of X minus energy of X. This is negative. But if an atom gives one electron, here energy of product X plus is lower value, whereas higher value, and this is lower value. So energy of product is higher value and energy of reactant is lower values. That is why it is positive. So delta H is negative means exothermic. Delta H is negative means exothermic. And an electron, so exothermic means associated with the liberation of heat, liberation of energy. So next, here also similar to ionization potential, everybody listen. For example, chlorine and oxygen, let us consider electron gain enthalpy values. Electron gain enthalpy values. Chlorine neutral atom, gaseous atom, gains one electron, forming chloride anion. During this process, some energy is released. So it is delta H is negative. Delta H is, Sri Vishnu, your doubt got clarified or not? So this chlorine gas plus electron giving chloride. Energy is released during this process. Let us take the case of oxygen. Oxide anion formula is O2 minus. O, you got to add 2 electrons. For a neutral atom, you are adding 1 electron, it becomes negatively charged ion. It becomes negatively charged. This blue colored words I am explaining now. Everybody listen. This slide, when an electron is added to uni-negative ion, this is called uni-negative ion. So if you add one more electron, this is also a negative charge. This is also a negative charge. We know that like charges repel each other. Like charges repel each other. So you have to spend some energy against the repulsive force. You have to spend some energy, so energy has to be supplied. So second electron, for the first electron added, the system will release energy, whereas for the second electron added, we have to supply energy. So electron gain enthalpy or electron affinity, first electron affinity is negative value, second electron affinity is positive value. Important to be noted. They will ask with respect to chlorine and oxygen very often. Make a note. If you have any doubts, you can ask. So when an electron is added to unit negative ion, energy is absorbed. X minus is unit negative. Electron is negative. Both are negative charges. Like charges is repel each other. You have to supply energy against the repulsive force. That is why second electron gain enthalpy is positive. So first electron gain enthalpy is negative, or first electron affinity is, some words are hiding, sir. Where it is? Oh, sorry, wait, sorry. So energy is absorbed to overcome the repulsive forces. So second electron gain enthalpy is positive. So first electron affinity process is exothermic, whereas second electron affinity process endothermic. Once again, right? Everybody listen. First, what is meant by electron gain enthalpy? Everybody note. You have a neutral atom. It has to be converted into ion. What is ion? It is a charged particle. Either a positively charged particle or a negatively charged particle. Let us consider both the cases. Here it is positively charged particle. Here it is negatively charged particle. All are in the gaseous state. Don't worry about the state. They are usually only in the gaseous state. So, in order to form a cation, the atom has to lose an electron. In order to form an anion, a negatively charged species, the atom has to gain electron. So, during the cation formation from a neutral atom, electrons are lost. One or more electrons are lost by the atom. During the formation of anions or negatively charged species from the neutral atom, one or more electrons are gained. So, removal of electron is equivalent to removal of some money or something from others. So, for removal of something from others, you have to spend energy. So, we have to supply energy here. In order to remove electron, we have to supply energy. If energy is supplied, this process is called ionization. Cation formation process is called ionization. Anion formation process is called electron gain process. But in the case an electron is gained by an atom, let us consider the example. Sodium loses one electron, for losing, it will not automatically lose. You have to supply energy. You have told sodium is not stable. Sodium plus is now only stable. It will be immediately, because it takes the energy from the atmosphere. It takes from energy from atmosphere, getting itself converted to sodium plus. That's all. That we are not supplying. It takes, like thieves taking our money, like that. So robbery. So they are not asking your permission for taking the amount, right? So here it loses electron taking energy from the atmosphere. But electron gain process means during this process energy is released. Chlorine, if it gains one electron, forming chloride ion. During the process energy is released. Energy is released. Here energy is absorbed. So energy absorbed means ionization potential or ionization phenomenon is endothermic. Energy released means electron gain process is exothermic. Anybody having doubt in these two processes? I can move only after this because lot of doubts have been created. Valid doubts only. First each of you get clarified about these two processes. Then only we can compare. So cation formation is called ionization. Anion formation is called is termed as electron gain process. Electron gain process. So in cation formation we have to supply energy. In anion formation the system will release energy. Anybody having doubt? So one of you can post a comment whether it is understood or not. Right. Con Deban, listen carefully. Right. Con Deban, let me discuss. Teach once again. So everybody teach again. Should I teach electron gain enthalpy or ionization potential? One of you answer. Those who have posted, teach again. Which to teach again? Again ionization process or electron gain process? One of you post. Simply post. Ionization means you need not fully write. You got to write. So ionization potential means you can post I, E, both, right? Okay. Everybody, please make a careful listening. See, you consider an atom X. Everybody consider an atom X in two different cases. X is a neutral atom. X is a neutral atom. It has to be converted to ion. What is ion? Ion is a charged particle. Ion is a charged particle. Charged particle can be positively charged or negatively charged. So if it is to form its cation means positively charged. If it forms its anion means negatively charged. Do you follow? So in neutral atom protons and electrons are equal in number. In neutral atom protons and electrons are equal in number because protons positive charge, electrons negative charge. 6 protons, 6 electrons means they will get cancelled. Or X protons, X electrons means total charge becomes neutral. But if it is a cation, protons should exceed the number of electrons. If it is an anion, electrons should exceed the number of protons. Number of protons. How can it be exceeded? In order to exceed, you have to remove one electron. You got to remove one electron. Whereas in the case, this process is called cation formation process is called ionization. cation process is called ionization, whereas anion formation is called electron gain process. Electron gain process. So Harshit, at present you listen to the electron gain enthalpy process. We can see about the ionization process bit later. Now everybody is aware of what is meant by electron gain process and ionization process. Ionization process is the process of losing of electron by an atom to form positively charged species. Electron gain process is the process by which a neutral atom gains electron to form negatively charged species. In both cases, so already we have seen what are the conditions. In the case of cation formation, protons should exceed. For that you got to remove electron, whereas you got to add electron. You take the common case, you take money. I am speaking about general tendency. I am not referring anybody. You need just quote an example. You need not mistake. If you want to give some amount to somebody else, he will happily accept. But if you want to get some amount from him, he will hesitate. So accepting the amount with happily, giving the amount with reluctance, with a little bit of reluctance. Similar is the case. If you want to remove an electron, you have to supply energy. So if energy is supplied, that is why ionization is endothermic. Endothermic means energy has to be supplied. Energy has to be supplied. Whereas exothermic means energy is released. Everybody make a note. You should not get confused. This will come in other chapter as well. Endothermic means supply of energy to the system. Exothermic means energy is released by the system. Energy is released by the system. Now let us see the case of electron gain enthalpy. Here it is the thing, definition. When an electron is added to a neutral gaseous atom to get its negative ion, enthalpy change. Enthalpy means energy change. Accompanying this process is called electron gain enthalpy or electron affinity. Both mean the same. It is symbolically represent neutral atom. When an electron is added, becomes negatively charged species. During this process, energy is released. Energy is released. That is why it is negative. Anybody having doubt in this slide content? Right. Now, since let me read once again. Since the energy is negative, the process is exothermic. That is printed here. Let me show it once again. So since the enthalpy is negative, process is exothermic. Right, good. Now, the case when X has become X minus. Now you add one more electron to X minus. For example, you have a family, a set of people residing somewhere. One fellow comes, he will accept with reluctance. One more fellow comes, you will reciprocate. How many this room can accommodate? Right? Like that. Here also, one electron is added means it has become negatively charged. Once again, one more electron is negative charge. Like charges repel each other. Like charges repel each other. So, in order to, so you have to add electron against the repulsive force. Against repulsive force. Like pushing a man into a room. In order to push a man into a room who are not accepting, you got to spend energy. Here also we have to spend energy. So it is endothermic. This is endothermic. So second electron gain process is endothermic. First electron gain process is exothermic. Second electron gain process is endothermic. First electron gain process is endothermic. So electron affinity, it is also a unit of energy. electron volt per atom or kilocalories per mole, kilojoules per mole. So let us illustrate. How does the electron gain enthalpy vary along the group, as well as how does it vary along the period? It increases along the period. Along the period, electron gain enthalpy or electron affinity increases, because so by this method, so if you have the starting from lithium, then you have fluorine, then you have inert gas neon. So electron gain enthalpy increases from left to right. So you should not consider for any case ionization or electron gain enthalpy. Noble gases should not be considered. Noble gases means they will neither give electron nor accept electron. They are neutral. So it is discarded here. Why it reason? Atomic size decreases. Size decreases means effective nuclear charge. So from left to right, increased number of protons. So effective nuclear charge increases. That is the reason. So electron gain enthalpy increases along group. Increases along period. Increases along period. Because the reason is effective nuclear charge increases along the period. Effective nuclear charge increases along the period. So now along the group it decreases. It will appear as though they are confusing with the words increase and decrease. You just note down electron gain enthalpy is inversely related to electron gain enthalpy is directly related to effective nuclear charge. Effective nuclear charge increases, electron gain enthalpy. Effective nuclear charge decreases, electron. This has to be noted. So electron gain enthalpy is directly related to effective nuclear charge. So effective nuclear charge decreases means electron gain enthalpy also decreases. If it increases, this also increases. That is the reason. We have told some rules, exceptions in groups. In all the cases, everybody note, whether it is ionization potential or electron gain enthalpy, inert gases will not be considered. Just now I have told. Inert gases, electron gain enthalpy of inert gas elements is 0, because it will not release energy on accepting an electron. It will not release energy because it is stable, completely filled. NP6 completely filled. You cannot add electron or remove electron. Optimal. So many people can be in this house. You will never accept new people, never lose existing people, like that. So it can neither accept nor gain. For inert gas it is 0. Second point, in the p block elements, first electron affinity of third period is greater than the second period. So fluorine is in the second period, chlorine is in the third period. So electron affinity of chlorine is greater than electron affinity of fluorine. Electron affinity of fluorine. The reason, along the group we have studied, size increases. Along the group, size increases. If the size increases, so along the group, if the size increases, don't worry about this one, it is referring to some other atom. along the group size increases. Size increases means outermost electron is farthest. So if you add one more electron, they will experience repulsive force. They will experience repulsive. So it will not release energy. We have to supply energy. In that way, we have to remember. Anybody having this doubt? This slide? Electron affinity of inert gas elements is 0 because of stable, completely filled NP6 configuration. A third group element electron affinity is higher than that of second group element because of increased size and stronger inter-electronic repulsion. Second point is correct. Along the group, study. Now, let us check with what we have understood today's class. What is electron affinity? So, electron affinity is always negative, always positive, E1, E2, E1 negative, EA2 positive. So, first electron gain enthalpy is negative, second electron gain enthalpy is positive. Just now we have seen oxygen plus forming one oxide ion, energy is released. But O minus one more electron, both are negative charge, you have to supply energy. So it is positive. Here it is negative. So third choice. First electron affinity is negative. Second electron affinity is positive. Reason is that second electron affinity, we have to spend energy against the repulsive forces. Against the repulsive forces. Nice, Kanishka. So, electron gain enthalpy order for halogens. For halogens, what is the effect we have seen? Electron gain enthalpy. Let's check. Good. Everybody is telling the answer for first question. Nice. Second question is that. So nice. Dhanalakshmi, Kon Deepan and Ganesan. Let us move to the second question. That is electron gain enthalpy or electron affinity for this one. Halogens. Generally it increases, but if you have to compare fluorine and chlorine, important. Very often question is both are halogens. Chlorine, one electron added, it will release energy. But fluorine, if it gains an electron, it becomes F minus, it will not release energy. It will not release energy. So it will release a positive energy. It will not release energy. Less positive, least positive. So that is why it is in the picture. So chlorine will release energy in the formation of chloride ion. Fluorine will not release energy because we will study the next property, last important property, electronegativity. Electronegativity, it will attract electron. It will so it will attract adjacent electron. Fluorine has the capacity to attract electron from any species. We will study later. What we have this Xe denotes the gas xenon. Xenon is inert gas. Xenon is inert gas. Inert gas will neither give electron nor accept electron. But this fluorine will attack xenon. Four fluorine atoms, like four thieves attacking a police. It will form. Xenon will be forced to lose an electron, 4 electrons, in the presence of 4 fluorine. You will study this. So there is a compound xenon fluoride, difluoride, tetrafluoride, like that. So fluorine will attack any species. So it will not give electron. So its value is 0. Zero group elements is nothing but inert gases. Inert gases, their electron affinity we have studied 0. So the value is 0. Which of the following has the highest electron affinity increases along the period we have seen, increases along the period. So if you go through the period, halogens have the maximum. Halogens have the maximum. Next is inert gas. Inert gas value just now we have seen they have 0. So halogens is the answer for this question. Good. Nice. Kanishka and Ganesh and Sivaparma. Now, everybody please make a note. This is an important property, electronegativity. Good. Dhanalakshmi for the previous question answer. So, electronegativity means capacity to attract. Capacity to attract the neighboring electron or electron from neighboring atom. Electron from neighboring atom. It is like stealing others' electron, other atoms' electron. So HF means hydrogen fluoride. So hydrogen has only 1 electron, but fluorine has 9 electrons. Fluorine has 9 electrons. The next inert gas to fluorine is neon. Fluorine will tend to attain this neon configuration because of noble nature. It will attract a hydrogen's electron. Hydrogen miserably contains only 1 electron. It will attract hydrogen's electron. So that is called electronegativity. So electronegativity is the capacity or power of attraction to neighboring electron. So electronegativity increases along period. And it is maximum for halogens. Amongst halogens, maximum for fluorine. Maximum for, just now we have seen, fluorine will attract inert gas electron xenon. 4 fluorine atoms or 2 fluorine atoms or 6 fluorine atoms, they will put together like a thief, will attract xenon's electron, forming xenon difluoride, tetrafluoride. So everybody make a note, electronegativity is maximum for halogens. Maximum for halogens. Still more maximum for fluorine. Still more maximum for fluorine. With these points, let us move to the definition. What is meant by electronegativity? The electronegativity is the ability of an atom to attract shared electrons. What is meant by shared electron? You consider hydrogen gas. Hydrogen gas means 1 hydrogen atom, 1 hydrogen atom. So this hydrogen atom gives 1 electron. This hydrogen atom gives 1 electron. It is at the center. This is called shared electron. We will see about sharing bit later. If you have hydrogen chloride or hydrogen fluoride, hydrogen has 1 electron. Fluorine has 9 electrons. So this 1 electron, 9th electron will come to the center. So it is common for hydrogen and fluorine. So first 1 electron of hydrogen and 9th electron of fluorine is common. This is hydrogen nucleus. This is fluorine nucleus. We consider hydrogen atom, 1 plus 1, 2 electrons. Helium is stable. If you consider fluorine, 9 plus 1, 10. It's like a compound wall. We have a compound wall between adjacent houses. Compound wall is shared by both the parties of the houses. Nobody can individually claim their share. It is my own, not like that. So Here, this compound wall shared electrons are stolen by fluorine. That capacity is called electronegativity. Power of attraction of shared pair of electrons. So, how does it vary? We will see. With this we can limit, but carefully understand. Ionization potential and electron gain enthalpy, it is not easily measured. It is not easily measured. There has no unit. Ionization energy has the unit of energy. Electron gain enthalpy has the unit of energy. But electronegativity has no unit. It is merely number. There are different scales of electronegativity. One is called Pauling scale. Another one is called Mulliken scale. Third one is called Aldred-Rochow scale. Just note down the names. No, but what is Pauling scale? He described electronegativity of a number 2.1 for hydrogen, and he has given other values. Whereas Mulliken scale, so Mulliken scale is applicable to monovalent element. Monovalent means valency is equal to 1, such as hydrogen, chlorine, sodium. So hydrogen, lithium, sodium, potassium, rubidium, cesium. Their valency is 1. Here fluorine, chlorine, bromine, iodine. Their valency is 1. So these compounds, it is applicable, Mulliken scale. These elements, it is applicable. What is it defined? He defined, it is easy to remember. Mulliken's electronegativity X is equal to average of ionization potential and electron affinity. What is meant by average? We got to add and divide by 2. Number of data, sum divided by the number of data. Here number of data is 2. Sum is ionization potential plus electron gain enthalpy. So don't worry about the numerical values, just have a glance. It is given for different units. It is not important. This is important. Make a note. Mulliken's electronegativity is the average of ionization potential and electron affinity. Electron affinity. Don't worry about the values. Lastly, checking the concept of electronegativity, what we have understood. Electronegativity has no unit. Has no unit. So fourth choice. Next question. Which scales measure electronegativity of elements? Pauling scale, Mulliken scale, all these. Next question. Right. See, let me use this. XM is electronegativity in Mulliken scale. Electronegativity in Mulliken scale. It is the average of ionization potential and electron affinity. Ionization potential is written as IP. Average means you got to sum divided by the number of data. 2 data are there. Ionization potential plus this one, right? Is the that is meant by electronegativity. The same question. Mulliken scale is applicable only for monovalent. Just now we have seen. Mulliken scale is applicable only for monovalent. Lastly, don't worry about these values. They will not ask question of this type. What is the value? You have the value, you have to compare. Hydrogen is called, everybody make a note. Hydrogen they will ask. Hydrogen is called electropositive. Hydrogen, lithium, sodium, potassium, rubidium, cesium, they form positive ions. So it is called electropositive. Halogens, fluorine, chlorine, bromine, iodine, they form negative. So they are called electronegative. So electropositive means electronegativity is minimum. Electronegativity is minimum. Let us check. So electronegativity, it will not be like this. It is given some number in that scale. Lastly, electronegativity decreases along group, increases along period. Decreases along group, with this we can limit. Electronegativity decreases along group and increases along period. Because increase in atomic size, these two are the standard factors. You got to compare size and shielding effect. This periodic table chapter, atomic size and shielding effect, you got to be thorough. With this you can explain easily. Electronegativity decreases because of the increase in atomic size and shielding effect along the period group. They have given the values. Along the group it decreases from 1 to 0.7. For halogens it decreases from 4 to 2.2. From 4 to 2.2. Along the period it increases. Fluorine is, halogens have maximum value. Fluorine is the maximum value we have seen. Decreases effective charge. So electronegativity is directly proportional to nuclear charge. Electronegativity is directly proportional to nuclear charge. Higher the nuclear charge, higher is the electronegativity. Higher the nuclear charge, higher is the electronegativity. Lower the nuclear charge, lower is the electronegativity. Like that. So these are just the values. You need not be fed up with the values. Just have the note down. This is to be noted. Most electronegative element in the periodic table is fluorine. Most electronegative element in the periodic table is fluorine, because fluorine will attack inert gases to form compounds. Inert gas will not form compounds, but nowadays they have detected the compounds, they have isolated the compounds of xenon fluoride, xenon oxyfluoride, like that. No other inert gas compound formation, you will see that. This. So factors influencing electronegativity, nature of bonded, already we have seen the effect of atomic size and nuclear charge. Nature of bonded atoms we will study in the next class, that is next chapter or next class. This is a new, that is why it is given. Let us know in brief. So it will be discussed in the. So inert gases have zero electronegativity, to be noted, because of stable configuration. So what we have studied in this chapter, please have a glance with this. What are the points? This is the essence. This you have to remember. So you cannot memorize like that. You have to apply the logic. Size increases along the group. Size decreases along the period. So electronegativity means non-metallic nature is there. Electropositivity means metallic nature. So electropositive systems will be metallic. Exception, hydrogen. Hydrogen is electropositive but not metal. So basic nature of oxides, basic nature means increases and decreases. We will see them in detail. Everybody please make a note in your, try to get the answers for the book back questions. If you have doubt, You can post, you can see later. With this, let us finish this chapter. So make a note, electronegativity increases means non-metallic nature increases. Fluorine is most electronegative. Fluorine is non-metal. Sodium is most electropositive. Sodium is metal. So electronegativity increases means non-metallic character increases. With this, let us wind up. Thank you.